Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution using Microsoft Excel and the shift algorithm. I also have a function that can do this for you using my stickpad E add-in, but in this video I'm not going to be using that. I'm just going to use Excel only. The video is about how to do this with Excel. To learn more about the concept of this distribution, I have a separate video for that. So the shift algorithm. I'll start off with a sample size of 5, and then the second thing I need to do is determine the maximum possible sum of ranks. That can be done with using this little formula, which simply says to take the sample size, so my n, multiply that by the sample size plus 1, so again this one plus 1, and divide it by 2. In my example that gives me 15. I then list all the values starting from 0 to that sum of ranks max, and that's what I've done here. So you can simply say, well, it's going to be 0, 1, 2, 3, 4, etc. You can do actually equals the previous one plus 1 if you want, and then just copy paste that down, and then we have the 0 to 15. All right. We create an initial list with a 1 and the rest of 0. So that's my initial list. That's over here. So I physically type in a 1 and then all the other ones are 0. After this, it becomes more interesting. We need to shift this whole list with a 1. So I'm going to shift all of these basically 1 down. So this 1, as you can see, has moved here. This 0 has moved here. And then because this one moves here, that basically means it goes all the way back up. Now we can do this with actually Excel. So as you can see here, there's an offset function that can be done. And what we're doing is we're going to offset the previous one. That's at least our cell reference for that. And if that's less than my sum of ranks value, then it's going to simply go all the way down to the last one, minus, and then actually the number of shifts that we're actually doing, and we add 1 for that because we want to go at least 1 further back down. It's not going to shift anything in columns, so I can copy paste this and then just copy paste this all the way down. I did enter the value 1 here, so, and that's about it. Alright, so this is the trickiest function in this video. The next thing is then to sum the results of the previous two. So we sum basically these two. That's what's done here. And that's our first shift. We then keep on doing this until we shift by up to and including actually our sample size. So my second shift is twice. And here I simply copy pasted that same formula that I had over here. So this is the same as this one, is just copy paste it. As you can see, it's actually shifting these now. So there's a 1 and a 1. It shifts by 2, so it goes 2 further down. So all of these up till the last one are the same as all of these. And these last two, they loop around again and they come up here. Again, we sum the results of the previous two, so these two now get summed, and that gives you these results. And then we repeat again for 3, for 4, for 5, and with 5 we've reached actually our sample size, so this is our last distribution. So these are the counts that are there. We can then actually also determine the proportions and the cumulative distributions. The proportions is simply to take each of these counts and divide it by the totals of all of these, so that's going to be 32, and that's what's done here. If you don't want to do the sum every time, you could actually also say, well, it's going to be the same as 2 to the power of, and then your sample size, that's 32, so then you also get that same sum. The cumulative probability is, the first one is simply the same as this one, and then everything after that is going to be the previous cumulative one plus the current one. And then you can copy paste that one down. So these three are the ones that form the distributions. For example, if I'm interested in a t-value of 6, so sum of rank of 6, I can actually notice that there are 3 different ways that that can be obtained. Out of 32, so that's a probability of about 9%. And to get a sum of rank of 6 or less, if we have 5 cases, it's about 41%. All right, I hope this was helpful, and thank you for watching.